Hey guys, welcome back to my channel. Today we would be learning about electricity. So what is electricity or electric current? Electricity is the flow of electrical power or charge. In electricity, the particle involved is mainly the electrons, the part of the atom with negative charge. It is the flow of these electrons through a circuit or conducting material by which electricity is produced. There are three types of circuits: simple circuit, series circuit and parallel circuit. Simple circuits. Let us observe this diagram carefully. We can see four circuit components: the cell, the switch, the lamp and the connecting wires. As we can see in this diagram, the current flows from the negative terminal of the cell towards the switch, the lamp and back to the cell through the positive terminal. When the switch is closed, the wires on either side of the switch are linked by metal contacts and a path is made through which the electrons can flow. Remember, the energy to move electrons comes from the cell. A few other circuit components include resistors, variable resistors as well as buzzers. A component that is designed to introduce resistance into a circuit is called a resistor. High resistant materials allow a small current to pass through them, whereas low resistant materials allow larger current to pass through them. If a short piece of high resistant wire is included in a simple circuit, the lamp will shine less brightly than before. If a long piece of high resistant wire is included in a simple circuit, the lamp will shine even more dimly. Variable resistor. In a variable resistor, the current passes through the terminal A along the metal bar through the sliding contact, the coil of wire, to terminal B. The sliding contact can be moved from left to right to encounter more resistance, as the current flows through more coils of the wire. The sliding contact can be moved from right to left to encounter less resistance, as the current flows through fewer coils of the wire. Buzzers. A buzzer converts electricity into sound when current flows through it. A part of the buzzer vibrates strongly when an electric current goes through it. It is these vibrations that produce the sound. Fuses and circuit breakers. What is the difference between the two? A fuse is a device containing a wire that melts when the current flowing through it reaches a certain value. When the wire melts, it breaks the circuit and stops the current flowing. Fuses are used to stop the flow of a current when it becomes too large for the circuit. They may be present in plugs or in the appliances themselves. A circuit breaker is a device that is sensitive to the size of the current flowing through it. If the current is too large, the switch opens and breaks the circuit. The switch can be closed and the circuit can be used once more, once the problem has been identified and corrected. Now we would be reviewing two important topics in electricity: measuring current and measuring voltage. Amperes. It is the rate at which electrons flow through a wire. The word ampere ammeter is connected into a circuit with its positive red terminal connected to the positive terminal of the cell. An ammeter is always connected in series with the component through which the current has to be measured. An ammeter has a very low resistance. Voltage. Voltage is the potential difference between 2 points. The word voltage can be shortened to volts and the symbol for it is V. The voltage or potential difference can be measured using an instrument called a voltmeter. A voltmeter is connected into a circuit with its positive red terminal connected to the positive terminal of the cell and its negative black terminal connected to the negative terminal of the cell or the power source. Remember, a voltmeter is always connected in parallel with the component through which voltage must be measured. A voltmeter has a very high resistance. Series circuits. A series circuit is a circuit in which the components are arranged in a chain, that is, lined up next to each other in a row so that the current has only one path to take. In reference to the first diagram as shown in the picture, the ammeter will record the same amount of current in each position A, B, C and D. If the lamps are arranged in series, their resistances combine, they add. The voltage across all components in a series circuit adds up. If there is a voltage of 1.5V and the lamps have a voltage of 0.5V, 0.4V and 0.6V, we can see that the voltages of the lamps add up and is equal to the total voltage of the power source. In short, 0.5V plus 0.6V plus 0.4V is equal to 1.5V, which is the total voltage of the circuit. Parallel circuits. A parallel circuit is a circuit in which each bulb or lamp has its own circuit. It has 2 or more paths for current to flow through it. In reference to the second diagram as shown in the picture, the ammeter readings vary in the following way. At points A and B, the reading stays the same. Whereas at points B and C, if the lamps are identical, the reading will be half of the readings of A and B. The total reading or the sum of the readings of B and C would be same as the reading of A and B, even if they aren't identical. The voltage across all components in a circuit would be same. If there is a 1.5V cell and 4 lamps are arranged in parallel, the voltage across each lamp in the parallel circuit would be 1.5V. Hit the like button, share this video and subscribe to